Can you believe it? Picture a cosmic event so huge that it casts shadows on Earth even in daylight. That's what might happen soon. Betelgeuse, a star in the Orion constellation, is acting strangely, suggesting it might explode into a supernova, lighting up our sky like never before. But when will it happen, and what will it look like according to scientists? What secrets might this event reveal? Let's dive deep into what's really going on with Betelgeuse and how it might affect Earth and the whole solar system. Betelgeuse, around 650 light-years away in Orion, isn't just any star. It's a red supergiant, incredibly bright, over 100,000 times brighter than our Sun. But why does it matter? Betelgeuse is special not only for its brightness, but also for its role in human culture. Named after the Arabic Yad al-Jawza, meaning the hand of Orion, it's been observed for centuries, guiding travelers and captivating stargazers with its reddish glow. Imagine a star so massive it could engulf our solar system. At 10 million years old, Betelgeuse is much younger than our Sun, but its immense size means it burns through its fuel faster, leading to a shorter life. Now nearing the end of its life, Betelgeuse is on the brink of a spectacular finale, a supernova explosion, releasing unimaginable energy and brilliance. The last time Earth saw such an event was in 1604 with Kepler's supernova, visible even during daylight for weeks. Supernovae like Betelgeuse's are rare, but their remnants offer valuable insights into the life cycles of massive stars. Betelgeuse's recent behavior has astronomers buzzing. Between October 2019 and early 2023, it underwent significant dimming, catching the attention of astronomers worldwide. Although it seemed to return to normal by April 2023, subsequent months saw its brightness surge by 50%, sparking discussions about its future. Could we be on the cusp of witnessing one of the universe's most dramatic events? Betelgeuse's unpredictable behavior suggests we might be closer than we think to a supernova explosion. Why the sudden change in brightness? Why did Betelgeuse, one of the most recognized stars in our night sky, suddenly throw a celestial curveball? Stars are not just twinkling dots, they are dynamic entities with life cycles, activities, and mysteries of their own. For many celestial bodies, periodic brightness variations can be predicted, much like the rhythms of Earth's seasons. In its stellar lifetime, Betelgeuse is known for a fairly consistent 400-day luminosity cycle. But with the great dimming, it seemed to rebel against its known nature, challenging our understanding of the celestial wonders above. Now you might wonder, are we on the brink of a stellar revelation? While the exact reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, centering around stellar activity and mass ejection, proposes a tantalizing scenario. Imagine Betelgeuse as a giant celestial volcano, suddenly erupting and spewing a colossal amount of its matter into space. Observations from the Hubble Space Telescope unveiled that Betelgeuse had previously ejected an enormous amount of surface material into the cosmos, a colossal event, 400 billion times the mass typically released during similar solar phenomena and equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense dust cloud around the star, affecting its apparent brightness and making it temporarily harder to observe. When this dust began to disperse or was pushed away by the star's radiation pressure, the veil lifted, potentially explaining its subsequent return to regular brightness levels. Either way, these recent events hint at a star that's not done with its surprises. Many speculate that Betelgeuse might be approaching the twilight of its life, a supernova event. A supernova is a cataclysmic explosion, an astounding burst of energy that can outshine an entire galaxy momentarily. This phenomenon occurs when there's a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star or, in Betelgeuse's case, from the exhaustion of its nuclear fuel, cascading its mass into the core and setting the stage for a cataclysmic collapse. What drives a massive star like Betelgeuse to its demise? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse kickstart their journey by burning hydrogen in their cores. This initial phase, known as the main sequence stage, lasts for millions of years and forms the backbone of a star's life. As stars run low on hydrogen, they evolve, embracing new energy sources. In Betelgeuse's case, as hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence phase to the helium-burning phase is marked by the star's expansion into a red giant. Over time, as helium reserves diminish, the star undergoes further expansion and shifts into other burning phases, each characterized by the fusion of progressively heavier elements. The bigger the star, the quicker these transitions occur, given the immense gravitational pressures at play. Then comes the climax. When iron starts forming at the core, unlike lighter elements, iron doesn't release energy when fused. The energy produced isn't enough to resist the star's own crushing gravity. The star balloons in size, creating an implosion followed by a massive rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse on the brink of an explosive end, or is it just biding its time? Recent research by Japan's Tohoku University suggests the star might be in its carbon-burning phase right now. Lead researcher Dr. Takashi Saito believes the core might collapse a few decades after its carbon reserves dry up. Not all scientists agree, however. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one thing scientists do agree on, regardless of these debates, is that Betelgeuse is slated to become the Milky Way's next supernova. Yet pinning down the timing of this event remains a cosmic guessing game, with bets ranging from mere decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse, one thing is certain: the universe always has surprises waiting. The fate of Betelgeuse, one of the most enigmatic stars in the cosmos, highlights a fascinating paradox rooted in the nature of time and light. When we gaze at the stars, we often forget that what we see is a glimpse into the past. Light from celestial bodies travels vast distances to reach our eyes, taking years, even centuries, to traverse the cosmos. For instance, Betelgeuse's light takes 650 years to reach Earth. This means that when we observe Betelgeuse, we are witnessing its state as it was during the dawn of the Renaissance, a time when explorers like Marco Polo were reshaping history. Each observation of Betelgeuse is akin to peering into a cosmic time capsule. If the star had already gone supernova, we wouldn't know for another 650 years. Discussions about its impending explosion reflect this temporal disconnect, as the event could have already occurred, its light merely en route to Earth. Recent revelations about Betelgeuse have sparked fervent debate in the astronomical community, drawing comparisons to the supernova SN 2023X, observed earlier this year in a galaxy neighboring the Milky Way. This supernova dazzled observers, momentarily outshining its host galaxy. Its brilliance and aftermath offer a tantalizing preview of what Betelgeuse's explosive end might resemble. The spectrum, intensity, and debris of SN 2023X provide insights into the life cycles of massive stars, making it a potential blueprint for Betelgeuse's fate. The connection between these events underscores the interconnectedness of the cosmos. Whether it's a nearby red supergiant like Betelgeuse or a distant supernova like SN 2023X, these phenomena highlight the dynamic and evolving nature of space. Red supergiants, as brilliant as they are mysterious, continue to intrigue scientists. Their life cycles, though broadly understood, are filled with uncertainties. These stars shed massive amounts of material in their later stages, a process integral to their evolution and eventual supernova. Yet, the triggers, rates, and mechanisms behind this mass loss remain a topic of intense research. Betelgeuse's recent fluctuations only add to this uncertainty. When Betelgeuse finally explodes, the event will be nothing short of monumental. Dr. Stan McMullen of Western University suggests that the supernova will temporarily outshine every star in the night sky, rivaling or even surpassing the brightness of the moon. For weeks or months, the night sky could turn into a pseudo-day, forever altering our perception of the constellation Orion. Over time, the luminosity would fade, leaving behind a planetary nebula surrounding the dim remnants of the star's core. Astronomers are also evaluating the potential effects of Betelgeuse's explosion on Earth. While cosmic rays released by the supernova could interact with interstellar material and potentially ionize it, Earth's atmosphere and magnetosphere would likely absorb these rays, ensuring minimal impact on our biosphere. Instead, the event would offer a spectacular light show, potentially producing breathtaking auroras while sparking global conversations and research into the nature of the universe. Beyond the scientific implications, the cultural and philosophical impact of Betelgeuse's explosion would be profound. The alteration of the night sky, a constant source of inspiration and reverence for millennia, would prompt reflections on impermanence, the vast scales of cosmic time, and humanity's place in the universe. Such an event serves as a poignant reminder of the ephemeral nature of existence and our enduring quest to understand the mysteries of the cosmos. This celestial drama encapsulates humanity's fascination with the unknown, bridging the tangible and the transcendent, and reinforcing our desire to comprehend the great beyond.